strange object, not only from our organs, just, in general, it weighs around 3 pounds, and it has the consistency of like soft jelly, and it just sits inside of your skull. That's it. And I don't know, somehow this little small organ, it creates everything that you know, all the information, it goes through your brain. Every color you see, every sound, every, I don't know, when somebody touches you, every song, now you listening to me, it's all processed in your brain. And memories too. All those memories that you have of your, loved ones or your embarrassing moments, they are all in here, right? So the brain is actually creating everything inside. So I'm going to explain how it works, and first thing that you need to understand that your brain doesn't experience the world directly, because the brain is trapped inside your skull. Like, think about it for a moment. Imagine your brain. It is just there in a dark skull. That's it. Literally. It doesn't hear anything. It doesn't see anything. It's never seen sunlight. So, but it knows a lot. This is because we have sensory organs, and they collect information from the outside and they convert it into electrical and chemical signals to our brain, right? We have 5 senses: smell, eyesight, touch, taste, and hearing. 5 senses, right? So, for example, when light enters your retina, right? Enters your eye, your cells in your retina respond to it. Those signals, they travel through your optic nerve toward your brain. It goes like this. Then your brain processes the information and it gives you what do you have to see? And it sends the signal back into your eyes, right? So that's what you see. So imagine that's how optical illusions actually work. So imagine you see something, there's like an optical illusion. Your eyes could possibly understand, they see, but the problem is your brain, because your brain isn't like familiar with this information, with this image, so you see something and you cannot process it, right? So this is why it's called an optical illusion. For example, let's talk about sound. You hear me right now, because sound is basically waves and vibration, right? Do you know where there is a big what is it called? For example, like what is it called? The thing that the beats, this one pill, I don't remember. Actually, when it produces sound, when it's very, very loud, it can vibrate. This is because of the sound, going out. So, as I speak, vibrations are in the air and they reach your ears, where they are eventually converted into these neural signals. Like here. Let's hear it. So your brain receives those signals and recognizes that it is a voice, it is a whisper, it is a lady's voice, it is calm, it is aggressive, it is sad, it's happy, you read those things. So in a sense, you never experience anything raw. Everything is goes through your brain, right? Reality is made from your brain, right? imagine it's like the internet, the Wi-Fi system network in your head, in his and hers and mine heads. The neuron, it is a specialized cell. If you don't know what a neuron is, I'm sorry if I pronounce it wrong. In Russian it's going to be neuron, so I think it's neuron. It is a specialized cell, and it is designed to receive and transmit information. It is unbelievably complicated network, and billions of tiny cells, they are communicating with each other. So let's go a little bit to a scientific side of this video. The usual neuron has a few structures. So the first structure is dendrites, whatever. These are like these things that receive signal from for example, from your ear. You hear something, signal, bam, dendrite gets the signal. Then there is a long extension from here, dendrins. There is a long extension. It is called axon, and it carries the signal to here, to the neuron. But actually, neurons don't actually like touch each other. There's a little like microscopic gap in between like neurons. It is called synapses. So imagine there is a cell, neuron, another neuron. Between them there is a gap. It's actually so tiny like this, and it is called the synapse. And when a signal reaches the end of the neuron, then this axon neuron, chemicals that are called neurotransmitters can be released into this tiny gap, synapse, right? It's very complicated. So these neurotransmitters, they bind to receptors on another cell and influence what happens next. You've probably heard of some like names of neurotransmitters like dopamine, serotonin. There are a lot of them. Basically, what we take antidepressants for, like serotonin. Why? Because as our eyes, those things are selective inhibitors, selective serotonin reverse inhibitors, whatever. So for example, dopamine, it's called the happiness chemical, hormone of happiness, but actually it's more about motivation, learning, movement, processing, reward, predicting what is going to be next, but it's just off topic. And actually, the next thing, different parts of your brain have different jobs. You may know it, like left and right. So your brain is not uniform. It's made out of different pieces. Imagine those pieces. These pieces as different. Every piece is like different color. So at the front of your brain, like here, there is a prefrontal cortex. It is very heavily involved in planning, decision making, controlling different impulses, and it's also about making predictions for the future, about consequences. This is where my stomach. So deeper inside, we've already talked about it. There's amygdala. It is, if I want to say very simple, it is about fear, right? You fear something because of your amygdala. Then there is hippocampus. We have also talked about it. Hippocampus, it's more about structuring, forming, and organizing memories. So that's why sit and there's like a bond. You have a memory. You know that this is bad, right? So that's how we learn, for example, not to touch a hot stove, for example, or don't jump from iced floor, whatever. So let's talk about your memories, because it's actually very interesting. Your memories are not recordings, because memory is not like a video. It's not like my birthday point MP4. No, it's actually reconstructive. Do you know when, like, forensic specialists, they reconstruct the crime scene? This is basically the same thing that's happening in your brain. So imagine you think again about your last birthday, and you remember everything like in details as you think, but actually you remember, okay, I remember the room, I remember my friend, I remember this music was playing, I remember the cake, I remember how I felt happy, it smelled like this and that. So, and every time you retrieve a memory, it can potentially be modified before it gets stored again. Please tell me that you get it. And actually, this is why sometimes two people can experience the same thing. They go to the same event, but they remember everything differently. I have a very good example for this. Do you know there are a lot of fights over, like, okay, do you remember this movie? Angelina Jolie was in it. And the other person says, no, it was Emma Watson. I swear it was Angelina Jolie. No, it was Emma Watson. I swear, like, I know it for a fact. And they just, okay, let's go to Google. And they go, and it can be a third actor, actress, whatever. Because we sometimes, because if we forget something, our brain can make new memories, like not make, fill in the gaps. So that's why, sometimes you think something happened and a different person thinks another thing. But sometimes we forget. It is not bad to forget things. Of course, if you forget too much, you have to think about it, like do something with it, maybe do different mental exercises, or go, even if you are over 60, 70, 60, you have to, go see a doctor. Sorry, I was just drinking water. So, but usually if we forget something, it's okay, because it's actually our brain decides what deserves attention. So forgetting is not a failure of memory, it's a good mechanism. It is an efficient system of keeping memories that you actually need. For example, imagine you remember everything from your birth, every license plate that you've ever seen, every code that has been sent to you to log in. We send you a code, please enter the code. Just imagine. Passwords, a lot of people's faces, all your embarrassing moments, everything. So it's actually very sad. It will be very sad to remember everything. The next chapter, I called it, why do we have emotions? Sometimes emotions can be irrational, that's what we think, but they aren't just, a useless interruption of our logical thinking. No. The emotions help our body and brain decide you? And they're like, yeah, sure. They give him $1 and shake hands. And this person goes home, he rubs his eye, he eats a sandwich like this, so it can be contaminated with something, because like homeless people are genuinely, they don't take showers and all that. So disgust saves us from contamination. That's why, some people say I cannot sit with my outside clothes on my bed, or for me, like, I have to wash my hands after I come from the outside. If I touch cash, I have to wash my hands, because I know how many people touch cash. So, but there's the problem. Our brains evolved in environments that were not very different from the modern life, So thousands of years ago, we could fear that somebody would attack us, but right now there is no like real danger. So that's why anxiety. I've talked about anxiety. If you want to watch this video, just type in on my channel anxiety. That's it. Let's talk about dopamine. Why your brain loves dopamine. I think it's my last. No, it's not my last. So, actually, why our brain loves dopamine? Because, for example, let's say you open your phone, no notifications, you close it. In 2 minutes, you check again. And why? Because it is called reward learning. For example, your brain is very interested in what is going on down in there. For example, what if it is an interesting text? What if somebody sent me money? What if maybe somebody liked your post on Instagram? Who knows, right? Or for example, why do we scroll so much? Because again, it is what is it called? Negative reinforcement or something like that. I forgot. Whatever. Imagine you're on TikTok or Instagram Reels. Imagine you watch a video, you swipe, and you never know what is going to be in your next swipe. What TikTok it is going to be. So that's why it's so hard to stop, because you're like, no, I'm gonna watch one more. No, one more, and you don't even notice how hours fly, So that's why we keep scrolling. Let's talk about neuroplasticity. It is basically how our brain changes. So your brain it's not fixed after you grow up. It's always different. Like, you learn new skills, you do something unpredictable, a lot of skills can develop your brain's ability to work better. For example, I know for a fact, one neurobiologist, he's a scientist, I've watched his podcasts, and he said that actually to avoid dementia, for example, right, when you're old, for example, learning a new language, it's cool for your brain, but it won't help. What will help is learning how to play an instrument. So guitar, piano, whatever. If you learn, it's going to be so good for you. So you have to practice a skill, and the networks involved in that skill, they become more efficient, right? So for example, repeated habits, they can also change the brain. Even if you repeatedly think of something, it will strengthen certain patterns of processing. This is what I'm talking about. If you're always knowledge you had 10 years ago. And then there is consciousness. It is something, it is so, it's the biggest mystery, because scientists can study neurons, electrical activity, all those axons, everything like that. They can study the parts of the brain, but consciousness, how? Like, why do we feel like something? Why do you feel like, oh, I want to eat a banana? Why? Okay, maybe you're hungry. Why do you think of a banana? Why not apple? Like, why? For example, I love this smell, I love this perfume, and someone else says, oh, I hate this perfume, it's too sweet for me. Why? Why do we have these preferences? Why does red looks red? And I want to answer your questions about different things. Like, I know for a fact that a lot of people, when they were little, they were like thinking about, what if I see red as red and my friend sees red as blue, and we see the same thing. We see different things, but we call it the same. Actually, we all see the same. It's just, some people have my brain colorblind people, and it is actually, there are only colorblind people, that's it. Other than that, we see the same. But what about taste, for example? Let's talk about taste. It's just something that I want to add right now. For example, why does somebody like milk and somebody doesn't like milk? Who knows? But I know for a fact there is a gene. Tell me in the comments if you have this gene. It is responsible for bitterness. So some people, if you have this gene, you are more sensitive to bitter things like coffee, grapefruit, gin tonic, a lot of bitter things. So tell me in the comments, like, what are you sensitive to bitterness? Because nobody from my family, they are fine, but me, I cannot. Like, my brother, he drinks straight coffee, black coffee, no sugar. I'm like, I've tried it. I'm like, how do you drink it? That's just my gene. That's it. I learned it a long time ago, actually. I'm telling you this just right now. So, also there is a thing like, why do we find this music beautiful? What parts of the brain are tickled? They're responsible for music taste. Actually, I don't know this. The strangest thing is that your brain is currently trying to study itself. We are talking about the brain, and it's all in your brain. Just look at this video, look at your phone or your laptop, whatever, iPad. Everything you see is in your brain. I don't know what else I can say. Oh, and just to add, I just remembered that neurosurgeons, when they operate on people's brains, sometimes, actually quite often, they leave the patient conscious, because when they are in some parts of the brain, they have to have like response from the patient, if they can hear, if they can see, if they can count, if they remember something. So they are conscious. That's it. Somebody